Hi, Joe Piezinski here with Advanced Innovations again. I want to say thank you to everybody that has subscribed to that last video and to my channel and given me all the positive feedback. Thank you very much. The more good feedback I get, the more feedback I get, the more these videos I'll do for you. And if you have a specific question, specific need, you're running up against a wall with a little problem, you think I can help you out, put it in one of the comment lines and I'll see if I can get to it. Okay, today we're going to go on the mill and I'm going to show you how to set a precision angle without the use of an expensive sine bar or gauge set, and it's certainly going to be more precision than you would get using a protractor and a scribe. Now I know that there's guys out there that can scribe a line on a block and cut it and actually split that line. I'm one of them, so this really isn't for you if you're that good, but this is a technique you might want to put in your arsenal and take care of. Anyway, I'm going to take you to a zone now that you're probably not comfortable with. It's trigonometry. Now if you're going to start doing bolt circles and patterns and angles and stuff, ultimately you're going to need to know angles and sines and cosines and tangents and all those other functions of angles. But I have a little cheat book for you right here. This is the Illinois Toolworks Trigonometry Table book, and you can find these online. You can find them with Manhattan Supply Catalog. They're really handy to have, and I'm going to show you exactly why you should have this, or at least be familiar with the technique. All right, I've taken the liberty of drawing a 20-degree triangle on this piece of paper. Now the things that we know about this triangle are this hole right here, and this length, and this angle. Okay, that's all we know. We know we have a specific angle, 20 degrees, because that's what we want to cut on our part. This is our part. Stupid little part. But let's say you have 100 of them and you need these angles to be spot on. You want to make sure that you do it right and it doesn't look like it was done with a hacksaw. So we have a base length and we have an angle. Now with that, knowing that we have a certain projection and a length, there's only one value that we can come up with for this side. If we go in the trigonometry tool table book here, this is a right triangle because this is a 90-degree angle here. And if I were to draw that better for you, there we go. Now it's a right triangle because that's a 90-degree symbol and we got it going on. Now inside this book you can have an area where you want to find angles, which is not what we want to do because we have the 20. Or you can find sides, which is exactly what we want to do because there's our triangle. We want to find this side right here, which is our side here. Okay, so if you look real close, this is side C, and this is so easy. You can't be intimidated by this. You got to try it. We have the 2" 500, which on this representation here is letter B. We have the 20 degrees, which in this example here is the big C. So we want to find the little c, and that's this column right here on the far left. So it narrows it down to the bottom 5. We want to find C, but we only have the little b and the C, and that happens to be the very last one on the page. B, which is 2.500 times the tangent of 20 degrees. Now each angle has a tangent, a cotangent, a sine, a cosine, a secant, and a cosecant. Now this is probably Greek if you've never done trigonometry, but if you can turn the page in a book, you got this down. So we have 2.500 times the tangent of 20 degrees. So in the back, there's all the angles on all these pages in the back. So we find the column that says tangent, which is this, and this is just a straight 20 degrees. It's not 20.5 or 20 degrees 30 minutes, which is 20.5 degrees. It's 20 degrees 0 minutes. So this is the little M for 0. Look straight across, 363.97, a 5-place decimal. So 2.500 times that value, tangent of 20 degrees, gives you 910. And for all you guys that are going to go grab your calculator and try this, it's actually 9.09959. It's about 19 decimal places long, but it's only like a 2/millionth of an inch off of 910. So we're going to go with 910 for now. Now that's important because this is going to be your bolt hole pattern when you start popping holes in a piece of stock, which is what I took the liberty of doing off camera. 1 3/4-ish tall, 4.5 inches long, 251 diameter holes. They're reamed because I have a reamer. If you don't, use a 1/4 inch drill, but be careful that you're not cutting a 257 hole or a 260 hole. You don't want it to get too oversized, because that's going to defeat the purpose of what I'm going to show you. I'm going to assume that you don't have a huge set of gauge blocks or gauge pins. As a new startup or a garage shop, very few people make the investment in elaborate sets of high-class gauge blocks and gauge pins. It's very expensive. So let's go with the next best thing. Worn out end mills. I know everybody's got worn out end mills laying around, and they're always precision ground on the shank. So a 1/4 inch end mill is close enough for what we're doing. Bear with me, I'm going to put this camera, and it is really hot where I'm standing right now. 92 degrees in my shop, so if my face is red, it's because there's a red light from this GoPro, and it's 92 degrees, and I'm ready to go home. Anyway, let me mount the camera for you and show you what this is all about. This is a good one. All right, because we're going to be depending on the back side of the machine, or the back side jaw of your vise, you're going to want to make sure that it's flat. This is called an indicol, I-N-D-I-C-O-L, indicol. And this is a best test indicator. I'm going to lock that on the spindle, take the machine out of gear so I can spin it easily, and I'm going to register that indicator against the top surface of the back jaw. Doesn't have to be on 0, just has to be close enough. Now sweep the top of the back jaw to make sure that it's flat. That is about 1,000th-ish worth of movement. If I had more time, I would take that jaw off and clean underneath it, because I know these are ground and they can be true, but 1,000th of an inch over 2.5 inches is not even worth talking about. Thermal expansion will give you errors greater than that. Let's move the vise back over in front of the camera. Okay, now with the 2 holes drilled in your plate, you know you have exactly a 20-degree relationship between the bottom corner and this right there. That is 20 degrees. So if you were to stand this up in the machine like this and lay something against here, it would be at 20 degrees. Same thing we're going to do with it laying in the machine this way. Now, to save time and to not throw chips all over the shop, I took the liberty of making several at a time, and I sawed this one off on the bandsaw. Now naturally you're not going to want to saw it off on a bandsaw and brag about it, so let's play with those holes for a second. Stick the end mills in the holes. Make sure you leave some full shank out either side of the part, and register on the back jaw that you just proved to the world was flat. Gentle downward pressure between the pins. Make sure the part is centered in the vise. Clamp it. Okay, these are relatively snug right now. They wiggle a little bit, which is okay, but we know this part is now sitting at 20 degrees. I'm going to take a dust cut off of here and make some noise, so bear with. Okay. Now by simply going to the tool tables or the trig tables, and you can probably find that stuff online as well, drilling 2 holes and using 2 pins, I now have a precision 20-degree gauge block, and I would guarantee this is within minutes. And a degree is broken up into 60 minutes. I will guarantee that this is within 5 of those 60 minutes, which is well within the tolerance you're going to get from most reasonable requests. So you can see by looking at the block, this side here is absolutely parallel with the center line here. It's nice and long, so it gets across the gap that you're going to find in these Kurt vices, because the movable jaw has this casting underneath that slides in and out, so the center is lower. You want your gauge to go across it. When you get your part, you put your part in here. Bear with me. This is actually kind of hard to do with the camera right in my face like this. There you go. I'm down on the block. When you cut it, now it's a flat surface. But if you have that, and you have more than one, the next time you open this vise, this part is going to slide downhill. You have two choices. You can set a stop for the part, or you can set a stop on this. When you have this in the vise, resting on your pins, you can drill a series of holes in here. 1/8 inch diameter holes would be fine, 1/8 inch drilled and reamed. You can use dowel pins in here and use that as a solid stop, or since you made it so fast, cut a hard step in it. So now the stop is solid. It's aluminum, it's cheap, you can make another one. I have two vices on my machine. I'm going to set a piece of stock in the vise on the right hand side, bump the angle stop up against it. Now every time I stick a piece in here, it's on the gauge block stop. The stop is up against the vise stop, and this isn't going anywhere. I can pull this in and out of here 100 times today, or I can put 100 pieces in here and they're all going to come out looking exactly like that. That's all I got for you today. Depending on your hole pattern, you can regulate and control the angle of your blocks. You do not have to make a block for every single degree. Having them 1 through 5 and then 5 through 35 is probably a good idea. Now I'm sweating because it's hot in here. Or if you want to get your checkbook out and go to one of the supply catalogs, you can buy a set that looks like this. But until which time you decide to spend hundreds of dollars on precision ground equipment and you need to get the job done now, that is certainly one way of doing it. If you like what you saw, give me a thumbs up. If you need something specific, stick it in the comment line. I'll get back to you. Thanks for watching. Thanks for subscribing. Bill Piesinski, Advanced Innovations, Austin, Texas, out.